Okay, guys, the topic today will be I'm gonna talk about the gracial and cuneate tracts, and this is will I'm pretty sure that this will be a little longer, but compared with the other videos, but I also believe that will be relevant for your studies. And before I start, don't forget to like, subscribe, and if you were watching me here on TikTok, consider to follow me and share this live with other people. I usually do live streamings like this every day from Monday to Friday at 9:30 a.m. And the topic is mainly about neuroanatomy, and is focused in this structure that I believe that is one of the most complicated structures to study when you are studying an anatomy in general. Now, talking about the the structures, let me start saying that the spinal cord contains long ascending fibers that are part of the posterior funiculus, and it also know this the posterior funiculus is also known as dorsal column, and these fibers are responsible for transmitting sensory information from the body to the brain. And till this point, I believe that you already know this, especially because I've been mentioning about posterior horn, anterior horn for about maybe 10 videos now. And yeah, well, specifically they care proprioceptive sensations, and what is proprioceptive sensation is basically the body awareness. Okay, is all this ability to understand where is your body in the space, and also the light touch sensations. Now, there are a few tracts that I will be talking here during this live. One is the gracial tract, which is this one, and the other one is the cuneate tract, which is this one here. Okay, and this topic I truly believe that is relevant for any manual therapist, especially those that want to learn more about the human body and how they can because once you know these structures, you can make the links necessary to understand what is working and what is not in your patient when you receive your patient in your clinic. Now, the gracial tract is located medially. Okay, the gracial tract is located medially. If you consider that here we have the midline separating the right side of the spinal cord from the left, and it's also located in the posterior funiculus. Okay, and the gracial tract, and this I mentioned before when I talked about the posterior funiculus, carries proprioceptive and light touch sensations from the lower half of the body, which is below the level of the diaphragm. And the fibers will originate from the dorsal root ganglia, okay? And the dorsal root ganglia houses the cell bodies of sensory neurons. The cuneate tract, which is this here, okay, cuneate tract, is located laterally in the posterior funiculus, and this I also mentioned during the live where I talked about the posterior funiculus. About the posterior funiculus, you can watch the full video on my YouTube channel, and the link for my YouTube channel is on the description of my bios here on TikTok. Now, the cuneate tract is located laterally in the posterior funiculus, and will transmit similar proprioceptive and light touch sensations, but from the upper half of the body, which means that it will be above the level of the diaphragm. And like the gracial tract, it also originates from the dorsal root ganglion. which is this one. I already made some illustrations of the dorsal root ganglion in other videos, so please just have a look at those videos, which are also like shorts or like how they call usually, I forgot the name, but when they cut parts of a podcast, it's like it's on my TikTok. Okay, is now. Thank you, Anna. Um, both tracts, okay, both tracts, the cuneate tract and the gracial tract, they ascend through the spinal cord and terminate in the medulla oblongata. And in the medulla oblongata, the fibers synapse in a specific nucleus. We have the gracial nucleus here, gracial nucleus, which receives input from the gracial tract, which is this tract here. Okay, let me just I'm gonna do this when I highlight. I use the ink to write over this sketch, but yeah, gracial nucleus, sorry, receives input from the gracial tract, and the cuneate nucleus, which is this one, receives inputs from the cuneate tract. And after synapsing this nuclei, the sensory information is relayed further via secondary neurons. Okay, via secondary neurons. And these secondary neurons will project to the higher centers in the brain, such as the thalamus. And here we have an example of the secondary neurons, and they will project to the centers, to the higher center in the brain. I mentioned the thalamus via pathways like the internal arcuate fibers, which is this one, and then the medial lemniscus. I'm gonna talk about each one in another video. Clinically, when damaged, the posterior funiculus in special, let's say due to trauma, compression, or disease like syringomyelia, it can result in sensory loss in the affected dermatomes. And patients usually experience loss of proprioception, which is difficulty sensing body position and movement, leading to, let's say, unsteadiness and imbalance. So patient will have difficulty to stand up and find the body center. Okay, loss of light touch sensation will be reduced. And what else? The pattern of sensory loss depends, of course, on whether the damage affects the gracial or the cuneate tract. If affects the gracial tract, usually the sensory deficits will be on the lower limbs and trunk, and if affected the cuneate tract, the sensory deficits will be in the upper limbs and face. And let's say that lesions at the medulla or medullary lesions, let's say if they damage the gracial or cuneate tract, it will lead to complete loss of proprioception and light touch below the level of the lesion. And damage to the thalamus usually disrupt the final relay of sensory information to the cerebral cortex, resulting in more widespread sensory deficits. What else I can talk? Let's talk about each one of these structures. And here I have the dorsal root ganglion. Okay, dorsal root ganglion. And the dorsal root ganglion contains cell bodies of sensory neurons that send axons into the spinal cord, and they are essential for transmitting sensory information from the periphery to the central nervous system. Now here we have this. I've been talking about the dorsal root ganglion for a while now. So I think that if you already follow me for more than a few weeks, you probably know very well what I'm talking about. Okay, so dorsal root ganglion. Not bad, no? Okay, so this one. Okay, and then we have the most lateral fibers of cuneate tract, lateral fibers of cuneate tract. Fibers of cuneate tract. Guys, I really appreciate if you can tap in the screen, because this helps to send this live to more people, and I don't receive anything from this video, so tap will be a great help if you can do this. Okay, lateral fibers of cuneate tract, and these fibers are part of the cuneate tract, okay? And they will basically carry sensory information from the upper body. Cuneate nucleus. So let's talk about the cuneate nucleus. This one here. Cuneate nucleus. And the cuneate nucleus is located in the medulla oblongata, okay, and receives input from the cuneate tract, which is this one here. Cuneate tract. Okay, and acts as a relay station for sensory information before it ascends to the higher centers through these internal arcuate fibers. Now the gracial tract, which is this one here, is a medial tract. Okay, gracial tract. Gracial tract is located in the posterior funiculus, is more medially, and carries sensory information from the lower body. Then we have the accessory cuneate nucleus. Accessory cuneate nucleus. And the accessory cuneate nucleus is a small nucleus, as you can see here, and is adjacent to the cuneate nucleus, and is involved in processing certain types of sensory information. And its role is less well defined, to be honest, compared to the primary nuclei. But I think that it's still important to mention this nucleus here. And what else? We have the cuneo-cerebellar fibers. Cuneo-cerebellar fibers. Okay, and these fibers project from the cuneate nucleus to the cerebellum. So I can do this here. Okay. And they are important for motor coordination and balance, and also integrate sensory information with motor commands. What else? Internal arcuate fibers. Internal arcuate fibers. Okay. They are secondary fibers that connect the gracial and cuneate nucleus to the medial lemniscus. And what I'm gonna do? I'm gonna do this. And here we have the medial lemniscus. And the medial lemniscus is major and ascending pathway in the brainstem, and it will carry sensory information from the gracial and the cuneate tracts, gracial and cuneate tracts, to the thalamus. Okay, I'm gonna write up here the thalamus, and I'm gonna write it like this. Okay, medial lemniscus. This is the medial lemniscus. What else? Medial lemniscus is important because relays proprioceptive and light touch sensations to the ventral posterolateral nucleus of the thalamus, which is another structure that I will talk later in the future. Now, we also have the collaterals to nuclei of posterior horn. Collaterals to nuclei of the posterior horn. Posterior horn. Okay, and some fibers from the posterior nucleus, actually from the posterior funiculus, may branch, okay, off and synapse in the posterior horn of the spinal cord, and these collaterals contribute to local reflexes and modulating, and also in modulating sensory information within the spinal cord. So let me just do this. Okay. Okay. I already mentioned about the gracial nucleus. I don't need to talk again. And what else? Okay, let's just wrap up this part here. The posterior funiculus of the spinal cord contains two ascending tracts, gracial and cuneate, and they will transmit proprioceptive and light touch sensations from the body to the brain. These tracts will originate from the dorsal root ganglion, ascend through the spinal cord, and terminate in the medulla oblongata, where they synapse in the gracial and cuneate nuclei, which is gracial and cuneate nucleus. Okay? From here, sensory information is relayed to higher centers via internal arcuate fibers, and the medial lemniscus. And it will reach the thalamus and the cerebral cortex. Damage to any part of this pathway can result in significant sensory deficits, impact proprioception, and light touch perception. And yeah, this is actually what I wanted to share. I hope you got the information. Hi, Lisa. Yeah, that's it. This is what I have for you. Okay. I want to stay here, but this part I will finish. And don't forget, if you're watching this video from my YouTube channel, consider to subscribe, to make a comment, to share. Everything will be helpful. Okay? And if you are watching from TikTok, consider to follow me. And that's it. Thank you.